logo built by the community. So let's get to the actual talk. So we're going to talk about a completely language agnostic topic today called GraphQL. Not every talk is going to be language agnostic. That's not a requirement. We are going to use Ruby on Rails quite heavily in this talk. You don't need to know Ruby on Rails. You don't need to know Ruby. You're just going to be able to follow along. And again, the code's not going to be the important part. It's more the concepts that we're talking about today. That said, if you do know Ruby or you do know Rails a little bit, or if you've used a Rails-like framework like PHP's Laravel, Python's Django, .NET's just .NET MVC, there's a handful of other ones too, then you're going to see some similar concepts here. So don't worry about the fact that we're using Ruby too much. It's just a language that I love, and obviously John and I used to run the Ruby group. So I'm just forcing my will upon you. That's really what's going on here. So how to GraphQL? By me, I'm Aaron Krauss. I'm the code boss on various social media networks. I really don't use social media that often, but I'm still the code boss. That's never going to die. I work at a company called Clevyr. That's the fancy shirt I'm wearing here. A couple of my coworkers are here too, but we are a software consulting company in Oklahoma City. We're about a mile north of here. We work with companies, we work with local individuals, anyone who wants to pay us to make them something software, websites, mobile apps, DevOps work, anything. That's our game, that's what we do. We've been around for 10 years or so. We're always looking to hire. I think we're looking for Ruby on Rails and people with a Java background. That's like, I know that's opposite ends of the spectrum there, but again, we want everybody. So if you are looking for a job, hit me up as well. I used to be a board member of Techlahoma, kind of like Lucas said too. I'm no longer anymore, but I've been pretty active in the community for a while. And last but not least, I am a code.org volunteer. You can always sign up here if you want to. That just means that teachers at K through 12 schools can ask me to speak at their school, and I can say no, I can say yes, etc. It's just an opportunity for me to basically work with schools to do any sort of programming-related teaching thing. If you do volunteer, you're not going to get hit up every week. I haven't done it in over a year or so, and I think I've gotten one email in that time about it. So it's kind of a, you do it, and you might get hit up, you might not, but it's pretty sporadic. That said, it's really fun. So what's GraphQL? Let's get into the meat of the talk here. So the actual definition, well, that's the nice image right there. If you see that, that's GraphQL. So this is the actual definition you're going to get. It's not my definition. GraphQL is an open source data query and manipulation language for APIs and a runtime for fulfilling queries with existing data. Take that as you will. It's relatively easy to understand, but also not at the same time. My definition that I like to use is just GraphQL makes querying data a lot simpler by allowing the client to control querying the data that it needs. And we're going to see that a lot here today. That's kind of a big benefit. It's also really simple once you have it set up, and there's a couple reasons for that we'll get into. GraphQL is language agnostic. It is a concept, kind of like REST. There's no, you can't just download REST for your application. It's a structure, you build it. GraphQL is the same way. You have to use a tool to implement GraphQL, but the ideas behind it are you can use it in any language. It's also database service agnostic, and here's a pretty good visual about what that means. So, and this is not a GraphQL specific thing, but the idea here is that we've got various clients here. They're going to hit a server that's running GraphQL, and GraphQL can tie to a legacy system, a various database, a microservice, third-party API, etc. This is not GraphQL specific. You could build a REST server to do this. You could build any server to do this. But the point being is that GraphQL out of the box is going to ship with the ability to cater to whatever you need. It doesn't care about whatever your setup is. You can implement it however you need to. So itself is just a spec. It's not an implementation. There's several implementations. Probably the biggest one you might have heard of. If you've heard of GraphQL, it's called Apollo. We're going to talk about that a little bit today. But you're going to want, like I said, you can't just go to a GraphQL website and download GraphQL. You'll have to use a tool to use it. So some important dates, just talking about the history of GraphQL. So GraphQL started in about 2012, which no one knew it started then, but it was built internally by Facebook then, and they use it internally with their mobile app. They released it to the public after one of their conferences in 2015. That's about when the public finally heard about it. And in 2018, it moved from Facebook to the GraphQL Foundation. So it's no longer under the Facebook umbrella. There's no worry that Facebook is going to snap their fingers and take it all away. Even React's not like that anymore, though. For a few years, there was kind of the scare of what if Facebook just makes it so I can't use React without abiding by their license. That's not a concern with GraphQL. No longer under Facebook's umbrella. So, two key concepts to know with GraphQL, and I'm gonna throw a lot of random things at you, and I'm not worried about them sticking because when we do the demo, a lot of things are gonna stick. But the two key concepts that I think are important are GraphQL enables what's called declarative data fetching. This is the whole idea behind it. If I am a client, a mobile app, a web application, whatever, and I need certain data from the server, if I'm using REST, I am limited to whatever that server is going to give me. I can't decide what I'm going to get back besides changing the endpoints that I'm hitting. With GraphQL, as the client, I can decide what data I want to get back. If I want to get only a name from a user, that's it. If I want to get back only a name and something else from a user or a relationship, I can decide that from the client. That's the declarative nature of GraphQL here. Second thing, and this is where the simplicity really comes in, GraphQL is just a single endpoint. With REST and several other things, you have several other endpoints. For a large web application, it'd be easy to get into hundreds of endpoints. And that's completely fine. It's that that's how we build things today, largely. GraphQL exposes a single endpoint, and that is for reading data, that's for writing data. I guess that's really all you can do with data, but it's for anything you need. It's the single endpoint. And because it's a single endpoint for reading and writing data, you are making a post request to it. And we're going to see this during the demo. This is where we're deviating from REST a little bit. REST is very big on following the HTTP spec. You send a GET request to get data, you send a post request to create data, put request to update, etc. GraphQL, we don't do that. Everything's a post request because it's a single endpoint that's just handling one request. And we need it to be a post request because whether we query data or we're mutating data, those are two key words we're going to use here. It's the same request. So post is kind of the catch-all that handles that. So there's three things you can do with GraphQL. You're probably thinking only three, there's a lot more, but there's three core things you can do. And they're also known as operation types. I'm going to try to throw whatever the actual words are that GraphQL defines on their doc. So operation types are the three things you can do. And it's these right here. Queries, you can query data, aka read. You can mutate data, aka write, create, like insert, update, delete, anything with writing data. And you can subscribe to data. We're going to talk about queries and mutations today. We are not going to talk about subscriptions. I couldn't reasonably fit that into this talk. But the idea behind subscriptions, you probably can guess what it is. You can subscribe to data that is created, that's updated, that's deleted. If I delete a record in a table and I want to get notified of that immediately, I can hook up a subscription and subscribe from my client to that and get notified of that immediately. We're going to focus on queries and mutations today, and I don't know, I'm pretty pumped about this. So why would you use GraphQL over REST? We've talked a little bit about the benefits of GraphQL, but how do they compare to the problems that REST has? So the big one is it solves the idea of overfetching and underfetching, and that probably sounds weird because those are two separate terms. But the idea of overfetching is getting more data than you need. So if I am loading up a web page and I only am just showing a name, like a blog post, for example, or maybe not even a blog post, but just a list of blog items, I just need the name, maybe the date. I don't need the whole body. But if I'm querying an endpoint that lists all my blog items, I'm going to get everything. At least if you're building a pretty standard REST API, you're just going to send back the whole item, the whole blog post, the whole list of blog posts. Well, that's overfetching because on this big list page, I don't need all of that data. That's a lot of content that I'm wasting bandwidth on, I'm wasting my data plan on. I don't need all of that. So with GraphQL, I can easily tell the client only load up the name and the date or whatever else I need. It also solves the problem of underfetching because a lot of REST endpoints are single resource endpoints. If I need let's say I'm showing a blog post on this list page, all the blog posts, but I also want to show the user that wrote the blog on the same page. That could be two REST requests. One to list all the blog posts, one to list all the users, and one, and then client side maybe I would match them up. With GraphQL, and I'm sorry, that's the underfetching side of this. I can't just make one request on REST to get all of the data that I need. So one query to get all the blog post items, I'm not getting everything. One query to get all the users, I'm not getting anything. So I have to make multiple requests, which then leads to overfetching. With GraphQL, I can say, give me the blog name, give me the blog date, and give me the user, and then give me the name underneath that of who wrote it. And that's all a single query. You're still, there's still database queries on the back end, but as far as what's happening over the network, that's just one query. So GraphQL really helps out with this. And again, this is dependent on how you build it, but the idea is you could build a terrible GraphQL API, you could build a terrible REST API, but all things the same, you can really solve this problem a lot better with GraphQL than you can with REST. If you try to solve it with REST, then you're kind of breaking REST and that you're really catering things specifically to your client. With GraphQL, your client is the thing that you're building it for. So you don't have to cater to it, it's catering to itself, really. So this is important for increased mobile usage, and this is why GraphQL really has gotten popular, and this is why Facebook even thought about it in the first place. We are lucky enough in the United States to not be really beholden by crazy data plans or low data plans, although that still is definitely a concern. I don't want to be paying several $100s a month for loading up data that I don't need. But in other parts of the world, this is a much bigger concern at this point in time. So Facebook created GraphQL with the idea of being able to limit exactly the data that it needed from endpoints while keeping it pretty flexible. So very important for mobile usage. Development speed is increased. This is a big one. Your front-end developers can now actually don't have to depend on a back-end developer to make a server change to get the data that they need. That's communication time you're saving. It's mental, it's cognitive load that you're saving. As a front-end developer, you can just get the data back by sending an extra query, an extra word right here, by saying you want to get this extra field. It's super powerful. You're not cutting out a back-end developer by any means. You need someone to set this up, but you're really giving a lot of power to more of the development team with this, and that's just going to increase speed. And the last one is it's going to support a variety of front-end frameworks. And again, this is you could do this with REST theoretically, but GraphQL is largely tool-driven, so you're going to have, like I mentioned, Apollo earlier is a big one. There's Apollo tools for Angular, for React, for Vue, for whatever your favorite front-end framework is, versus REST. There's definitely tooling around to help with that, but REST, again, abides largely by the HTTP spec, so you kind of have to re-implement a lot of it in whatever your framework of choice is, because there's a lot of niceties that GraphQL gets by being kind of a big tool that you're going to use. So what companies use GraphQL? Well, these and many, many more. But just to prove that this is not just like a fake thing, companies are using this. I think you already knew it, but here's the obligatory people who are using GraphQL. I'm kind of surprised Facebook's not on here. That's funny. I'm pretty sure they still use it. So let's get to some of the code behind the stuff. So our plan with this, we're going to build a Ruby on Rails application, and I'm not going to do any live coding. We've already got the stuff built. We're going to go through the code, though. So we've got a Ruby on Rails application. It's going to be tied to a Postgres database, and we're going to use GraphQL with it. Relatively simple idea. The data, we're going to talk about what we're going to do. We're going to explore queries and mutations. So again, we're not going to touch subscriptions today, but these are the two big things that you will be able to do with GraphQL after today. So our data structure is going to be very simple. We're just going to have a user, and they're going to have items. In this case, they're books. The books are going to be books I've read in the last 8 months or so with my fun descriptions I've given those books. So let's hop to the demo. So the first part of the demo, we're going to set up the project. Again, it's already set up. I'm just going to walk through a little bit about how Ruby on Rails application works. We're going to install a GraphQL library, already installed. We're just going to talk about it. And we're going to talk about how Rails is going to handle routing and then getting us to the point where we're at that one single endpoint for GraphQL to handle everything. So all right, let's dive into some code. Can everyone see this okay? Cool. So I've got a Ruby on Rails application set up here, various files here, just to kind of walk through the key concepts. Some of you may already know Ruby on Rails, but if you don't, Ruby uses gems for package management. So we have a gem file here. This is like your package.json. It's like your mix file if you're looking at Elixir. Whatever your favorite language's dependency tool, this is it for Ruby, a gem file. And this is where we list out all of our dependencies. So you can see Rails is going to be on here, a bunch of other things. Our GraphQL ones we added are right down here. GraphQL is the GraphQL Ruby gem. That's what we're going to use here. And this gem right here is GraphIQL. That's just going to be an interactive GraphQL query thing we're going to use just for demo purposes. So as far as the actual Rails application goes, there's two big concepts that we're going to talk about today. We're going to talk about this app folder here, and we're going to talk about the routes. Was there a question back there? Yes. Ooh, that's a good question. So does GraphQL itself manage this gem, or is it community-driven? I don't know. It's pretty high fork-wise on GitHub. I want in the several hundreds. I think the organization was Ruby GraphQL. I don't think it was under the GraphQL Foundation. I'm not sure. Yeah, I don't know. We'll just leave it at that. It's pretty popular, though. So with how a Rails application works, we've got our routes file in our config directory there. And this is our routes file right here. Very simple. And this is not even a requirement. If we're in development, we're going to load up our interactive query URL. That's all this is saying. This is our single endpoint for everything GraphQL. We're saying if we get a post request to /GraphQL, whether we're going to route it to the GraphQL controller, the execute action. That's what we're going to talk about next. This one is for something else. I've got a little client-side demo that I'll show at the end if I've got time. It'll be pretty quick, but this is just another route, just the root route, actually. And it'll load up the library controller index action. But this is the one we're focusing on now. So this is going to route the logic of post-GraphQL to the GraphQL controller, the execute action. So where do the controllers live? Well, they live in this app folder. If you've ever used Laravel before, it's a very similar idea. Inside of here, we've got a controllers folder, which is going to have our GraphQL controller. So routes is just matching the name of what we said there to this controller, and there's going to be a function in here called execute. So I'm going to hop to the top here. So we've got a class GraphQL controller. This was generated by the tool. I did not write this, and I will try to call out what I generated, what I built myself, and what was generated for me. But the tool itself, Rails is a very nice framework, as well as other Rails-like framework, in that it generates a lot of code for you, and there's a lot of magic involved. That's up to you to decide if you like that. I personally like that a lot. But kind of with that idea, a lot of the tooling you're going to get with Rails is going to be a lot of, they're going to have generators built in. So I installed the GraphQL and tool, Ruby GraphQL. I ran an install command and it installed like the boilerplate code. This is one of them. So I did not write any of this. We're not going to dig too deep into what this does because I didn't even dig into it myself. But it's hitting this function right here, execute. It's going to parse our incoming query, which you're going to see in a little bit, and it's just going to return this right here, this demo schema thing. Everything in GraphQL revolves around what's called a schema file, and that's what we're going to talk about next. It's called demo schema because my directory I'm in is called demo. That's my Rails app, so it just kind of named it, but schema was added afterwards. But this is it. This is how we're getting from the actual incoming post HTTP request to the actual logic here. This is the end of everything. So let's kind of go over what we're going to talk about next. That's how we got to the GraphQL logic. That part was pretty simple. I mean, I don't want to say it's simple, but quick to demo. Next things we're going to talk about are creating a schema file. We've already got one created. We'll talk through it. And that's the core idea of GraphQL here. Everything that we're going to do revolves around a schema file because that's what our tool, our GraphQL tooling, is going to read to know what it can do, what it can't do, and that's it. Once we create a schema is going to have many types inside of it, and it's going to have different references to those types. So a type here, think about it as like in this database, I've got a user and I've got an item table. I'm going to have types for both of those, so I can specifically say these are the fields that I'm allowing on this type, the user type. These are the fields I'm allowing on the item type. And after we create our types there, we're going to test a query. So we're going to see everything right now. So back to my Rails application, when I installed Ruby GraphQL, and now we're getting into, a lot of this is obviously Ruby specific, but we're getting into tooling specific stuff now. This might not be identical to how the Apollo tooling for a Node application would work, or the whatever GraphQL tool you're using for Python would work, but the concepts here are going to be the same. Exact code files might not be. But in this actual tool, it created a directory called GraphQL, automatically scaffolded. It created that's a demo file. I created that accidentally. That's not supposed to be there. It doesn't do anything. But the actual tool itself created directories called mutations, types, and this demo schema. Again, that's just named after my directory, demo. And let's start off with this. This is our actual schema file. If you see RB, that's just a Ruby file. And this is all generated. I did not build any of this. But let's walk through it a little bit. So this is just going to say, we've got this is our root schema file. We've got our list of mutations here. We're going to talk about this later in a little bit. This is the one we're going to talk about now. We've got all of our queries listed here. So in Ruby, this just means that we're inside of a module, and this is a class inside of that module. If you've ever used languages that have the capabilities of what are called mix-ins, by being able to mix together modules and classes, this is an example of that. Ruby's pretty prominent with mix-ins, but it's not a Ruby-specific thing. So we're loading up all the queries here in this object called query type, which that itself is going to load up all of our other types. These down here, this is just boilerplate code from the tool. I didn't create that. I'm not going to act like I know what all it's doing. I'm sure their docs talk about that. But these are the two important ones. So let's dig into query right here. So what that's going to do is load up. So I've got a lot of files in this types thing. That's what we're going to talk about next. These were all, everything that started with base, like right here, completely generated. Did not build this. Scaffolded out immediately. I'm telling you, Rails libraries love to scaffold things out, and it's awesome. Again, your own opinion there, but I think it's awesome. I did create two of these files, actually, item type and user type. Those are those two tables that we've got in our database right now. Mutation type and query type, I did also, those are also scaffolded, but I did edit these. So let's take a look at query type here, because that's what we're digging into next. So from the root schema, we're getting all of our queries from here, and this is our top level query right here. All we can get are items, basically. So this is where we're getting into how GraphQL works. With everything that you're querying, and let me just do a demo real quick, and then I think we'll be able to see a little bit more. If I've got, so I'm on localhost 3000, I'm running my Rails server. I've got this GraphQL, this is that route I was telling you about. It's that if Rails development, then load up this. This is just a little fun interactive tool. But if I, let me just, I think I've got like a description here. If I just run this, I'm getting back data, like I'm getting stuff back. And I've got two tables here, items and users. They're not here, but just in this project. So I'm loading up my 5 items that I've got here, and I've got the descriptions here. Now, let me actually pull the full query, because I've got it saved in my notes file here. Oh boy, that was like barely any difference. Okay, bam, magic. So we're not getting back the description field anymore, we're getting back ID and title. And this is, so the way this works is we're making a post request to our GraphQL endpoint with this as the payload right here, and we're getting back this data right here. This is the power of GraphQL. I can add fields here, I can take them away. For every field I have, this resolves to a function on the back end, on the GraphQL, on my type object right there, and that's what we're going to talk about next. However, I do want to just dig into showing you exactly how this request is being made. Whenever I make this request, I'll try to zoom in a little bit on this. You can see these are hitting the GraphQL endpoint. I click on that and it's making a post request. Every time I make a request from this tool, it's making this post request. And when I go down to the actual payload we're sending, this is the payload it's sending. It's sending query, and then whatever I'm passing there, this items, ID, title, etc. It's stringifying everything that I have right here. And it's got variables as null. We're going to talk about variables when we get to mutations. But what this tooling is doing is wrapping up this right here and putting it inside of the payload that it's sending to my GraphQL endpoint. Now, this fully works when you're querying data from GraphQL. You can just send back a JSON-like blob. I'm sure this is just GraphQL language is probably what it's called. However, what a good best practice to do is you should always specify what you're actually doing. And there's a prefix you can do here with the GraphQL query, and this with the GraphQL query here. And this is your operation type. So there's 3 things you can do. This goes back to that thing we talked about a while ago. You can query data, you can mutate data, or you can subscribe to data. This first word should be one of those 3 things. If it's not there, you're going to query data. That's it. It's required if you're mutating data or subscribing to it. It's always good to be explicit, though, just again for documentation purposes and everything. So if we run this, we're going to get the same data. And there's another thing that we should be pretty explicit about, and we should add in what's called an operation name. And this is no bearing on anything. Our server doesn't care about this, but it's good, again, for documentation purposes if I do that. And that's the end of all the random stuff we can do. If I do like foo afterwards, I'm pretty sure it's going to break. But GraphQL itself understands these first 2 words right here. So again, this is the operation type. We're specifying what we should do. This is the operation name. It's not super important as far as what the server cares about. It's more just for documentation purposes, but try to be explicit. And again, if we just remove this, it's going to work just fine. And like I mentioned earlier, with the idea of underfetching, what if we wanted to get a list of item titles here and get the user who created them? Well, we've got a user set up on this, so I can just get something like that. I've got a full name field already set up, and bam. These are 2 different tables, item and user, where a user has many items, so there's a foreign key on the item to the user. We're querying that data from the back end, but we're not making 2 network requests, we're just making 1. And we're just getting the data right here. So this solves that idea of underfetching. So we kind of looked at how this request is being formed to the backend. Let's talk about how you can actually set this up. So this goes back to our type. So we've got an item type here, and this is actually a user type here. And everything on here is a type. This is just there's scalar types. This is an integer. This is a string. User is a user type though, so it's a little more complicated. And you can kind of see, it's an ID type there. And GraphIQL, I'm not quite sure if I'm saying that right. It might be GraphQL. It might just be Graph Interactive QL. This thing right here is pretty nice in showing you and kind of helping you. So like, for example, if I, I can, oh boy, my hover thing is there. Yeah, so I can kind of see what capabilities I can get here. Just a nice little tool. So let's look at how this is actually set up on the back end. Let's look at the item type. So we're back in this file, I think right here. No, we're in this one. So we're in query type, and all we can do on our query right now is we can get an item. So that's the only thing I can have at the top root right now. Even though I have user table on my back end, I don't have user on here. It's going to error if I try to do anything on this just because I haven't specified that I have a type for it at the root level. I can only query items. And for every field that you're querying, which right now items is a field, and then these are all fields of the item object type, you have to have what's called a resolver function. And this is key to how GraphQL works. For every single field you have, and that includes like the attributes of an object, you have to have a function that resolves what that field is actually getting. So for items here, we're just specifying this word field that came from the Ruby GraphQL tool. We're specifying an item symbol. This is just a string. This is actually a Ruby specific thing. If you see colon, whatever the word is like this, that's a symbol. So we're specifying a field called items. We're saying it's going to return an array of item types here. We're saying that it's okay, or we're saying that it can't be null. You have to specify items in here. So if we were to leave out items, it would yell at us. And then just a description here. We don't ever see that when we're querying the data. This is more for if you have a tool that wants to scrape for a GraphQL schema, this will help you build it. Like I'm sure somehow, returns a list of items. That's our description right there. So it's in the schema somewhere. Items right here is our resolver function. So in Ruby, this is how we define a function, def items. With Rails, the ORM we're using is called active record. A lot of tools like Laravel and Django have ORMs that are very similar to it. We're just getting all the items. That's actually making a database query to our database. We're just getting everything, all fields for all items. So that's our resolver function here. So we're still querying all the data for the server to the back end, but we're just not returning it over the network. So we're getting items here, and then the magic really happens in this item type right here. We're specifying item types here, and then we're going to get a response of that. So let's go to item type and see how that behaves, and that just goes into here. And if you're wondering how I know what files I'm going to, that's kind of the magic of Rails. Rails has what's called its asset pipeline. It knows exactly where to find files, and largely that's based on how you name them. But item type, for example, is right in here. It's inside of this module, so kind of bouncing back. That's why we wrote it like this. Rails asset pipeline, it's magic. If you like it, that's awesome. And that's where I'm going to end it. It's awesome. So we've got another type here, and this is, I was going to say this is the end of our types. We do need to explore user types in a little bit. So we've got an item type here, and this is where it's the exact same thing as we did before. We had a root type that's just called a query, and we built a resolver function for it. We have the same type of thing here. However, you're probably noticing we're missing the resolver functions. And I would say you're kind of right, but that's also not correct, because what happens is ID, title, description, image, URL, those do actually resolve two functions. They're just not functions that we had to define. That's what we get from using active record, our nice ORM. These are attributes in the database: image, URL, description, title, ID, etc. User, however, is not a user doesn't exist in the database. We have a user ID. However, active record gives us a user function on it, so it still resolves to a function. So we didn't have to build resolver functions for this, which is nice. Again, that's the combination of active record and this tool right here. Again, if you're using Eloquent with Laravel, whatever Django's ORM is, you're going to get a similar benefit here. We're specifying the return type, an ID, a string, and a string right here. And we have a user type here. And that's why when I say user right here, I can do things like specify the fields of a user here. It all has to do with this user type. And then null just means that they are required fields. Like if I created it without, if I were trying to create an item without a title, or if I were trying to retrieve a title from the database without one of these things, it would yell at me. So I need a title and an ID. I don't need a description or an image URL. I do need a user. So let's hop to the last type we're going to talk about, and that's the user type here. And it's going to be very similar to this. We could have added probably another type like items on here. I didn't do that just for demo purposes, but we could have had a field on here called items that would have been a list of item types. These two are kind of like I mentioned with the item type. We have a bunch of fields that relate to database fields. So ID and email, those get added from the database, and active record automatically knows how to wrap them up in functions. Full name, however, is not an active record. That's a combination of the first name field and the last name field, just exists in the database. It's a computed function, really. So that's why we put this resolver function here. And our tooling is going to know what that resolves to. So we already by this point in time, we've already gotten the data that we need. So if we go back to the query type right here. This is the actual moment that data was queried from the database. Beyond this, when we dig into the subtypes, like item types and query type or user types, we already have the data itself. So we're getting object.firstname and object.lastname. That's not making any queries. That's just using what we've already gotten in memory back from the database. And I think there's nothing else. Yeah, there's nothing else beyond there. So this is a computed field here, so that's why it's going to behave the same as that right there. And we'll just go through, in case you were just wondering what these books were. Frankenstein, in my description, is a monster. It's pretty nice at first, but then he's mean. I'm reading Dracula right now. It's pretty cool. And The Handmaid's Tale is very depressing. I read The Hobbit. Felt like I was playing D&D when I read that. And then Life of Pi, where I found out that tigers are pretty neat animals. Anyway, that's what I've been up to the last 8 months, just reading those 5 books. Okay, let's talk about mutations a little bit. So we've kind of talked about how queries work. Now, my big thing with GraphQL when I first learned about it was it's really cool to be able to query data like this, but what if I need to create data? First of all, can you even do that? Yes, you can. You can create data, you can update data, delete data, anything that you can do with REST, you can do with GraphQL. My bigger question was, can I only create data? Like, what if I need to create data and send an email with that, or send a job, like queue a background job for it, or I need to create an associative entity record with it, like do some other side effect logic. Can you do that in GraphQL? And you can. You absolutely can. And it all comes back to those resolver functions that we just talked about. You have to have a function for each mutation. So in the end, as far as mutations go, you're going to see a lot of the same behavior that you're going to get with REST, where you have like specific buckets of logic for doing mutations. The big benefit with GraphQL is the ability to query what you want to get back after that, or just query data in general. That's the biggest benefit of GraphQL. So let's do a quick test on mutations here. So let's do a demo of that real quick. Let me get back to my notes file here. Got a nice mutation here. So we're going to talk about how variables work here. We got a little bit more code here, but not a ton more. And I need to add one more. We're going to use query variables here. So I'm going to pass in just a blurb here, and we'll talk about all of this. So I'm going to hide that for now, just because that's not super complicated there. But if I run this, we should be adding an item, and then we'll talk about how all that works. Okay, so we did. So we added an item on here, and if I go back to what we had before, we should see at the very end that item we just added. So we can prove that we created the item. What this does right here, and I'm going to create another one just so we can see the response here. We created 2 items now. The way this works is, again, this is our operation type right here. We have to specify mutation now because we're doing it. Operation name, it's not required, but it's obviously you kind of want to, it's good for just verbose purposes, good for documentation, etc. Next, we've got our arguments list of what we're going to pass into this as variables. Can you hard code everything? Yes, you could. And that's more it comes into play here. You still need to specify the variables that you're going to specify for your GraphQL mutation function. But we're passing in query variables to this, title, description, and image URL. Let me just kind of make that a little bit, there we go. I'm only passing in title right now because that was the only one that was required. We'll add more though, and you'll be able to see that those get added. But we're specifying, I keep trying to move this over and then it keeps just coming back. So we've got our arguments list here about what our types are going to be, what we need to resolve them to. The bang there just means that it's required, so we need to have title. This part's important. So getting into the query itself, or the payload of the not query, the payload of the mutation, I should say. This is what we're actually invoking right here, this add item, and this resolves to a function on our GraphQL server. We've got some input values here. You can dig into a little bit more how that input key works. It just basically allows us to provide a list of attributes here. So we've got title, description, and image URL. Those are 3 things that we're allowing to be created on item right now. And this is what we want to get back when we return it. So we don't have to create data and then requery it. We can specify exactly what we want to get back. So if I am, like let's remove image URL, and let's just remove the whole user object in general. We could run this and get that back, but let's also, just as we've got an example going here, okay, there we go. This is JSON right here that we're passing in. Let's just put description there and put foo. So if we run this, we should get back ID 24, title, test, description, foo, and none of the other stuff. There it is. It's magic. It's GraphQL magic. Let's look at how this actually works. And you'll also notice we have inside of here data. That's what we had before when we were querying data. However, inside of here, we're getting back our add item key as well. That's the function that we invoke to query the data. And then we're getting back the actual data. It really just resolves to exactly how we told our GraphQL mutation to run. So let's look at, before we dig into the code, let's just look again how this worked, how this last query worked. Again, same endpoint, same post request. We're not doing anything silly or hidden. Our data here is different though. We added an operation name. I'm sure we added that before. I probably just didn't. I didn't have that in there. We got the same query, and it's exactly the same payload that we're passing in here. It's this whole thing is just getting stringified, and then we're passing in variables as actual JSON. This is the ideal way to set variables in your GraphQL requests. We could have just hard-coded like foo and test in the actual values right here. You might think that sounds silly, but if you're building it all client-side anyway, you're going to have those variables, and you would be able to do that, but it's not the ideal way. Again, it makes it less reproducible. You can't just copy and paste this and change out variables. You want to build your variables in your GraphQL queries like this by separating them out. But everything is the same. We've got our variables in there, a JSON, we've got our stringified query, etc. Let's talk about how that actually works with the server. So going back to our schema, we talked about the query part here. Let's talk about how we've got mutations synced up here. So we've got types mutation type, and that's going to resolve to this right here. And this is it. We've got one single line here. And this is our field add item here. You'll notice that this GraphQL tool is like camel casing it. I'm not sure if that's a spec thing or if that's just the tool itself, but right now this is a snake case function here. So that's our field, and we're binding it to this mutation right here, this mutations add item mutation. And that's where we're actually going to have the logic for how this works. So let's go into add item mutation. That's going to be on our mutations directory over here, which will be much smaller than types. It's just that. We've got our base mutation that was generated by GraphQL Ruby. We've got add item mutation. Probably looks like a long file here, but that's it. It's 24 lines. So digging into this a little bit more, we've got our arguments list here. So kind of like we specified fields with our types. When we've got fields here as well. We've got our arguments here, and that links to exactly what we're specifying here. And title is required, description is required, image URL is required. In fact, if I didn't have a title, let's just see what would actually, it's going to complain because I'm trying to bind something there. Let's just see what happens there. Yeah, so we actually get, this is not an error message that I generated. This is the tooling itself. Realize, hey, we're not passing in a title, but it's required. We're both specifying it here that it's required, and we're not getting it. So we've got required fields matched up all around. I'm going to add that back in here. So title is required, description and our image URL are not required. This field here, this is what we're going to get back after the query is done. So that's why whenever I am specifying this, let's create another one. We're getting back item here. That's one of the things we can get back. We can also get back errors if we had any errors. And in fact, if I just wanted to do that, I can run it, and then we're not going to have any errors. That was a successful creation. So an error is just going to be a string, an array of strings, actually. And we're just saying null true because it's okay if these are null. Like obviously error is null right there. We don't need to have anything for those. It's not a requirement. This is where the magic happens, this resolve function. And we've got our title, our description, and our image URL bound up here, and that's how we're accessing them in the in this function right here. But all we're going to do, and this is where you could put all your side effects. This is where you're putting the actual core of what this mutation should do. And it's probably going to look similar to REST. It's just a bucket of functionality that you want to do. However, you don't need to worry about response codes and everything like that. You're just actually sending back the data that you want to get back. So we're going to try to create an item. I could have put in, so right now, I'm not letting you put in a user. Like, I'm just going to choose the very first user that's in the database, and we're creating an item off of that. So if you'll notice that, like, we're getting like ID, it's always going to be 1. Like, there's no way you can pass that in. I could have done that just for demo purposes. I didn't. So we're always choosing the first user, and then we're selecting their items, and then we're creating a new one out of that with what we're passing in right here. So this title, description, and image URL is getting resolved to these variables right here. And then we're going to try to save the item. If it does save successfully, then that means that it was saved in the database, and we're going to return it. Otherwise, if we didn't save it, then we're going to get an error, and we're going to send back the message. And that's all there is to mutations. Just to prove that the error stuff actually works, and a little bit more about how Rails works, we've got our models, and we've got models here for item and user. That's just core Rails behavior. Let's put a validation on item where description is required. And let's just not even make it required here, but let's just pass in this. So according to GraphQL, it would totally be fine. Like, everything looks fine here. If we try to run this, we're going to get back null item, and we're going to get back our error. So just to prove that this is an actual Rails-generated error. Also, you can do validations in Rails super easy. Everybody use Rails. It's pretty awesome. I've actually become a Laravel fanboy, so I'm sorry, my Rails community. Okay. I think that's about it with mutations. You can get deeper than this, but this is the core concepts here. And all in all, what I've kind of found with GraphQL is there's a chunk of setup. There really is. A lot of this is scaffolded out, which makes it really nice, and I'm sure a lot of tooling does do that. But you obviously have to set everything up. Like, you have to build out resolver functions for every single field you want to return back to whatever your GraphQL client is. Not just like per item or per user, but like per resource itself. You have to specify all of your fields and how it's going to resolve to that. Also, on the back end, if we're querying data, like let's go back to one of our old queries like this. We're getting an item. We've got 3 fields here and then a user field here that's getting 3 fields. By default, because we're resolving this on a field-by-field basis, we have 6 fields here. I believe that corresponds to, here's my server right here. I believe that corresponds to like 6 database queries. You can optimize this, but by default, that's just how it's going to work because we're resolving everything. So yeah, we're selecting users. Boy, is that? Well, that's quite a bit more than 6, isn't it? Anyway, we've not optimized any of our queries here. That's not the purpose of GraphQL. However, you can optimize this. In Rails, by default, you're going to see a lot of caching here. Rails caches similar requests. So our actual application right here is not subject to this, but if you just went off the Rails and built this thing, without any sort of caching, you're going to be making a lot of database queries. That's not the problem that GraphQL is trying to solve. It's more of the network front-end type thing. But that said, you can easily cache this. There's, long-term, that's not an excuse. It's just something to kind of keep note of at the beginning. So the last thing I kind of wanted to show, and I know we're running out of time, and we're going to get out of here on time. No worries about that. Is the Apollo client. And I've got a little front-end demo here, which we're going to get all of our test stuff here. But I've, there we go. There we go. If I've got a React application here that is loading this up. It's using the Apollo client. I wanted to just really quickly run through how relatively simple that is. So with our Rails application, we've got I mentioned in our routes file, we've got this one line right here, root library index. That's what we're loading up right here. That's going to hit the library controller and look for the the index action. But if we go to that, that's this library controller right here. It's an empty function. We're not doing anything. The server's not doing a single thing, but by default, what it's going to do, it's going to return the view that matches up to it. So library index. Again, this is Rails magic. It's already binding all this for us. This is where we start doing everything. So we're loading up our index file. Again, this is a Rails helper here, JavaScript pack tag. It tells us that we can look right in here in this directory. If we look for index, this is where we're entering our first React file here. We've got, and this would be the root. We've got a little provider here, nothing really magic there. It just sets up some Apollo client stuff, and that's what we're using here. Basically telling everything within that to work with Apollo. If we go back to this, we've got a children of library here. We go to that, And this is it. Like, this is everything itself. We're just loading up. We're building a string for library query here. This is actually a template function in JavaScript. There was a good talk about template functions by Vance Lucas a couple years ago at OKC So if you have any questions about how template functions work, you can look that up on Techlahoma's YouTube. But as far as what this render function is doing right here is very simple. We are using query here. That's a component that Apollo gives us. We're passing in the thing that we're querying. It gives us a function back where we're deconstructing into two objects. So we've got data here and whether or not something is loading. So if it's loading, then we say loading. Once we have data, we're just rendering out the data that we get, and that's it. Like, we don't, to use GraphQL with React, for example, we don't have to use any stores. We don't have to do anything complicated. We're just kind of changing up how we build our queries. So this would be an example of what you could build for every React component. And again, just to prove that we could instead of doing title, actually I better just add description here. We could just change it up. And if I refresh this, it's going to take a second because it's going to recompile, but we should now get the title, the description. So we can just change it all on the fly. It's a full GraphQL query. No extra magic added. So that's kind of the end of the GraphQL talk. I feel like everyone always wants to know what comes after GraphQL, and I clearly have no idea. But I do want to share an interesting pattern that I've kind of found while working with GraphQL and researching it. Opinions following. Totally my opinions. So with GraphQL, it solved a lot of issues with REST. And REST was kind of known for being this really flexible thing that just basically was the core HTTP rules, and you're just using those to your benefit. There was already a rule set by HTTP. We're just using them. However, we obviously ran into issues where that kind of became inflexible. But for a decade or more, it's been awesome. But we kind of revolved around this idea of we needed a single tool to kind of handle everything that we wanted the client to be able to do. And that's kind of where GraphQL came in. We want the client to be the dictator of what data it's getting. And we don't want to have a developer kind of handle all that. On the back end would be a pain in the rear. So we have this big tool that is a GraphQL implementation tool that handles all that for us. And GraphQL is a spec for a system that revolves around a strong server tool, like I just said. Well, we've kind of had that before. And again, opinions following here. Before REST, we had a thing called SOAP, which is like a big tool that handled a lot of work for you. It made client-side development a little bit easier, but we obviously ran into problems with SOAP that then became a problem. It was really language specific, honestly. Like, if you wanted to use something besides .NET and Java, it was difficult to have the tooling. There were problems, so we decided to use something a little bit more flexible, like REST. Well, before we had SOAP, which is very, in my opinion, it's a strong server tool. Kind of like the idea of how GraphQL is. So before we had SOAP, we had just RPC, remote procedure call, which had a little bit of structure, but it was relatively flexible. I'm calling a function on a server, and I kind of liken that a little bit to how REST is. I'm just calling an endpoint there. There's obviously a lot of nuances I'm glossing over here, but the core ideas were kind of moving from flexible to something where a tool is providing a lot of work for you. And then we kind of move back to flexible and something where a tool is providing a lot for you. So I have no idea what the next tool is. It's just kind of a fun pattern that I've thought about. I feel like anytime I mention like GraphQL and SOAP, everyone runs away because it's a pretty bold argument to make. But the end argument is that, okay, I kind of mentioned this about RPC. It had a little bit more structure than REST, but it was a little bit pretty simple. So will the next thing being GraphQL is too complicated, too like big and too big of a thing? And I don't know. We're probably going to use it for 10 years and it's going to be awesome, and then we'll probably find something else. I have no idea what that thing's going to be. But that's kind of just, and that's the end of my opinions. It's just a fun thing that I've kind of thought about. Total opinions. I'm not saying any of that is fact whatsoever. You can throw your tomatoes at me now. I will accept it. If you want to know more info, there's actually a website called howtographql.com. That's why I named this title like that. And it's by the GraphQL Foundation. You can watch interactive videos about it. You can dig deeper. It's all free. It's great to get into it. And honestly, it's kind of funny that this worked out, because in a couple weeks, OKC Sharp is giving a talk over GraphQL with .NET. So if you like this and you do .NET, consider attending that. It's also at Starspace, also at 11:30 a.m., but it's on Monday, March 2nd. And then as far as our next talk is going to be that's their next talk. It's going to be next Tuesday, not next Tuesday. The next meetup's Tuesday, March 17th. It's also St. Patrick's Day. I don't think there's going to be booze here, but you never know. So you should come. There won't be booze, but you never know. The next talk is going to be given by Steven Vincent right here, one of the user group leaders. It's going to be microservices using Nest.js, and in the description, we'll post that within the next week or so. But I saw GraphQL was mentioned there, so I think that idea is going to come up again. And that's it. That's all that I've got. I'm Aaron Krauss. That's my website, thecodeboss.dev. I used to blog quite a bit. I haven't done that in a while. That's the company I work for, Clevyr. You can learn more about us at clevyr.com. And back to the OKC WebDevs logo. We don't have anything final to say about this, but I'd say maybe by the time the next meetup rolls around, we'll actually have something formal to either ask the community, or we might just go 180 and not do that. No promises at this point, but we'll say something about it. Okay, that's it. Any questions about GraphQL or anything? Yeah.
Anything you don't like or found frustrating so far working with GraphQL?
Anything I found frustrating with GraphQL? It can be a pain in the rear to set up, for sure. Like, the setup is just, it's annoying. But from having used it, after I kind of realized that mutations are just literal functions that you're executing, that was a big eye-opener for me, and that made me want to use it more and more. So really just the setup can be kind of a pain. But again, it really does revolve around a tool. So if you're tooling, like if you're using Apollo server, for example, that can be very good and very well documented. If your language does not have a good tool for GraphQL, it's probably going to be a pain. Yeah.
So the foundation provides a spec for the query. What queries look like? Does it do the same for what queries look like?
Does it do the same for what?
Errors?
So the foundation provides a spec for queries, and just the syntax in general. Does it provide a spec for errors? I don't know. Yeah, I have no idea. Yes?
The way that it's set up, it seems like it supports getting multiple queries just in one go. Is that the case?
Yeah, so the question is, can you do multiple queries in GraphQL? And yes, you can. You can build them up multiple queries at a time. And there's a project that we've worked on that we have done that. I don't know if we officially ever did that, but we explored doing it just because it's, you're saving network requests. So yes, multiple queries in one payload is totally fine. Yeah?
How do you handle user permissions? Is there any kind of middleware for you to do that?
So how do you handle user permissions? There's a big topic about how authentication works with GraphQL. And a lot of it's the same thing that you've been using with other tooling as well. But I didn't opt to put that in this because it was it kind of along with setup. It's not complex to set up, but it's a little bit of a different way to think about it. So as far as it goes, I'm going to say it's whatever architecture you're using, whether it's like token based or even just HTTP basic authentication or something. You can still do that. It's just kind of up to you to set that up. So there's no presets, but there are some suggestions on it. That's kind of where I'll leave that. It can be a little bit of a pain to set that up, but it's obviously you need that. Kind of answered the question, we'll say. All right, well, that's all I got. You know where to find me in Techlahoma if you have any questions. That said, just to reiterate one more time, Steven Vincent here is a user group leader. We got John Mosesman over there. Hit us up if you want to give a talk. Next meetup is on March 17th, St. Patrick's Day. Be here and be green. It's going to be a good day. And that is